class 9th, we'll continue our work in logarithms. In logarithms, we are going to do some more problems based on logs. Like the first question here is log x upon 2 is equal to log y upon 3. We have to find y to the power 4 upon x to the power 6. We have to find the value of y to the power 4, x to the power 6. You can clearly see that means we have to remove log from here because we want answer in terms of y4 upon x6. So we have to remove the logarithms. So let us cross multiply. 3 log x will be equal to 2 log y. There is no base given. That means it's a common logarithms, and common logarithm means to the base 10. This is 3 log x is equal to 2 log y. It could be written as log x to the power 3. It can be written as log y to the power 2. Now we can write log x cube minus log y square is equal to 1. Is equal to 1 because is equal to 0. Is equal to 0. You have transferred it to this side, so it will be left 0. Log a minus log b means log a upon b. It is x cube upon y square. It is equal to log 1 because log 1 to any base is 0. Log 1 is always 0, whatever may be the base. Here the base will be 10 because common logarithm is there. Now when both sides single logs are there, we can remove the log. We will get x cube upon y square is equal to 1. Or I can say y square upon x cube is equal to 1. Why I have changed the numerator denominator? Because I am wanting answer in terms of y upon x. So I have changed. But I have got to the power 2 here and to the power 3. But I want to the power 4 to the power 6. So I'll square both the sides. Or I can write y square upon x cube to the power 2 will be equal to 1 to the power 2, which is 1. Which is 1. It will be y4 upon x6 is equal to 1. That is what we wanted to find. We wanted to find what is the value of y4 upon x6. So we've got the value of y4 upon x6 is 1. Please see it once again. We cross multiplied. We brought the power multiples as the power by power law. That is 3 log x is equal to 2 log y. So log x cube minus is equal to log y square. I transferred both the terms on one side. Log x cube minus log y square is equal to 0. It'll become log x cube upon y square is equal to log 1 because 0 I converted into log 1 because I want to remove log. For removing log, I should have log on both the sides, then only I can remove the logarithms. So then we remove this log from both the side. We got x cube upon y square is equal to 1. But answer is in the form of y upon x. So I reversed the order. I wrote it as y square upon x cube is equal to 1. 1 upon 1 is 1 only. And then I squared because I am getting answer as y4 upon x6. So I squared both the side. It became y4 upon x6 is equal to 1. I have got the answer of for y4 upon x6 to be 1. Now let us see question number 2. In question number 2, we have to calculate two values, x and y, I think. Yes. He has given you log x upon log 5 is equal to log y square upon log 2 is equal to log 9 upon log 1 upon 3. Now these are ratios given equal to each other. Ratios are always going to be equal to a constant. it is already, this number is constant, because log 9 upon log 1 upon 3 is a number. So log x upon log 5 is equal to this, log y square upon log 2 is equal to this. From these two equations we will have to calculate the value of x and y. Let me take the first case A for example. Log x upon log 5 will be equal to log 9 means log 3 to the power 2, and it will be log 3 to the power minus 1. Why? Because if I bring the denominator to numerator, it is log 1 upon 3. If I want to make it 3, it will become to the power minus 1. So it will become 2 log 3 upon minus 1 log 3. So this will cancel, you will get minus 2. 2 upon minus 1 is minus 2. So log 5 upon log x upon log 5 is equal to minus 2. Or it will be log x will be equal to minus 2 log 5. Minus 2 log 5. So log x will be equal to log 5 to the power minus 2. I have taken the multiple as the power. I have taken the multiple as the power. You can always take power law. You have taken the multiple as the power. It will become log 1 upon 5 to the power 2. Because I want to change this from minus to plus, it will become log 1 upon 25. So log x is equal to log 1 upon 25. X will be 1 upon 25. This is the value of x. This is the value of x. Now for the value of y, I will take this and this equation. In the b part, what I will do is, I will take log y square upon log 2 is equal to how much. I have already calculated this to be minus 2. So I am not going to do the calculation again. I will write simply log y square upon log 2 is equal to minus 2. So log y square will become minus 2 log 2, or it will become log 2 to the power minus 2. It will become log 1 upon 4, because we will bring to the power minus 2 in the bottom, in the denominator, or y square will be 1 upon 4, or y will be plus minus 1 upon 2. It should be plus 2, 1 upon 2. In the logarithm, the values are always positive. Okay? Now let's look into the third question. Prove 3 log 4, 3 to the power log 4 is equal to 4 to the power log 3. A part, or first part is 3 to the power log 4 is equal to 4 to the power log 3. Now let's take log of both the sides. Take log of both the sides. Take log of both sides. Left hand side as well as right hand side. We can take logarithm of both the sides, not single. It will become log 3 to the power log 4 will be equal to log 4 to the power log 3. Now what we simply do is, we write them, the power comes as the multiple. So it will become log 4 into log 3, and it will be log 3 into log 4. Both are equal. Whether it is log 4 into log 3, whether it is log 3 into log 4, both are equal. So they are equal. That is what we had to prove. Second, B part. 27 to the power log 2 is equal to 8 to the power log 3. 27 to the power log 2 is equal to 8 to the power log 3. We take log again, it will become log 27 to the power log 2. It will be log 8 to the power log 3. Again, we can bring the logarithm in the beginning. Log 2 into log 27 will be equal to log 3 into log 8. Now in the first question, in the first part of the question, we could directly get log 4 into log 3 as log 3 into log 4, but here I am not getting, but I can see log 2 is here, log 8 is there. So 8 can be expressed as 2 to the power 3. Log 27 is there, log 3 is there. 27 can be written as 3 to the power 3. So log 2 into log 3 to the power 3 is equal to log 3 into log 2 to the power 3. 3 log 2 into log 3 is equal to 3 log 3 into log 2. So log 2, log 3, log 2, log 3, 3 and 3. So they are equal. They are absolutely equal here also, here also. It's just manipulation, nothing else. It's just manipulation. Question number 3 we have done. Let's see question number 4. In question number 4, I have first part is log x plus 1 plus log x minus 1 is equal to log 24. Is equal to log 24. Log A plus log B. Log A plus log B means log A into B. So it will become log x plus 1 into x minus 1. These things immediately should come to your mind. X plus 1 into x minus 1. A plus B, A minus B will give you A square minus B square. Is equal to log 24. So it will become log x square minus 1 is equal to log 24. So we are going to equate both sides because it is a single logarithm here, it is a single logarithm here. We can equate. So x square minus 1 will be equal to 24, or x square will be 25, or x will be 5. Plus minus 5. You can write plus minus 5, but generally whenever you take a square root, you take the absolute value, so plus 5. Now second part of this is log 4y minus 3 is equal to log 2y plus 1 minus log 3. Now it is log 4y minus 3 is equal to log A upon B. Log 2y plus 1 upon 3. Log A minus log B is log A upon B. Again, both sides are single logarithms, so we can remove the logarithms. So 4y minus 3 will be equal to 2y plus 1 upon 3. Cross multiply. 3 4s are 12. Minus 9 is equal to 2y plus 1. 12y minus 2y is 10y is equal to 10, or y is equal to 1. The value of y is 1 and the value of x was 5. So from this we have been able to find the value of x and y. Simple application of logarithm laws. Log A plus log B, log A into B. Once you have got log x square minus 1 is equal to log 24, we'll remove the log from both the sides. When you have single logarithm, I cannot remove the log here in this place. But once I have combined log x square minus 1 is equal to log 24, I can remove the log. If you want to remove the log from here, you cannot. What we did was log 4y minus 3 and combine this. Log A minus log B as log A upon B, and then you can remove the log because this is a single logarithm, this is a single logarithm. Then you can remove the log. Now let's see question number 5. Log x plus 2 to the base 10 plus log x minus 2 to the base 10. Log x minus 2 to the base 10. It is not necessary to, because he has mentioned the bases, so I will mention the bases. But if he does not mention the bases, that means the bases are technically common logarithm. Otherwise, he should mention the bases. Time and again, we are talking about this common logarithms. Common logarithms. Whenever the common logarithms are there, the bases are 10. Common base is always 10. So is equal to log 3 to the base 10 plus log 4 to the power 3 to the base 10. Now these are, again we are going to combine the left hand side together and right hand side together, change them to single logarithms, and then when we have changed them to single logs, then we can remove the log. It will be log x plus 2 into x minus 2, again a plus b into a minus b. Again a plus b into a minus b is equal to log 3 into 4 to the power 3. So x square minus 4 is equal to 4 4 is 16, 16 4 is 64, 64 into 3. This is 4 to the power 3. So 4 4 is 16, 4 is 64 and 3. 3 into 64. So 3 4 is 12, 3 6 18 and 119, 192. So x square will be 192 plus 4, x square will be 196, x is 14. X is 14. The value of x is 14. Sixth question is 5 to the power log x plus 3 to the power log x is equal to 3 to the power log x plus 1 minus 5 log x plus 1. So what we do is 5 to the power log x plus 3 to the power log x is equal to 3 to the power log x 3 to the power 1. It is 3 to the power 1 minus 5 to the power log x and 5 to the power 1. We have broken up, powers can be written as it is. Bring log 3 log x to one side or 5 log x to one side, 5 to the power log x plus 5 to the power log x and 5 is here. Then 3 log x, 3 to the power 3 to the power log x minus 3 to the power log x. 5 to the power log x is common, 1 plus 5. 3 is to the power log x is common, 3 minus 1. 5 plus 1 is 6. 6 into 5 to the power log x, and this is 2 and 3 to the power log x. So it will become 5 to the power log x upon 3 to the power log x is equal to 2 upon 6. 2 upon 6. 1 upon 3. 5 upon 3. There is something wrong. Just a moment. It's a question has to be x minus 1 log x 3 log, this is x minus 1, this is x minus 1, so it is 5 to the power minus 1, 5 to the power minus 1, so it will become 1 upon 5. It will become 1 upon 5, it is alright. Now here it will change. 5 to the power log x, and it will become 6 upon 5, and it will become 2 log 2 into 3 to the power log x. 5 to the power log x upon 3 to the power log x will be equal to 2 upon 6 into 5, or it will become 3. 5 upon 3. Here it is 5 upon 3. I can write 5 upon 3 to the power log x, and here it is 5 upon 3. So, when bases are same, powers can be equated. It is to the power 1. So, log x will be equal to 1. Log x is 1. The value of log x is 1. So, x will be how much? Suppose it is any base. Log x is 1. So, that means x will be how much? Log x will be 1. The value of log x is 1. The value of log x is 1.